Try this again.
Oh, I have a question. Which one would you put as a calculator for everything to the right? Inverse 0?
You would never.
Never.
Never. It's a very good point that Aaron brings up. Inverse norm is always area to the left.
So is there something in the calculator that's the area to the right?
There is nothing in the calculator that will do area to the right.
So are you going to get any problems about the area to the right or something?
You could.
And then you would just reverse it and then subtract from 1 or something like that?
Subtract from 1.
So you would get you would do the inverse norm of, let's say it was like the nut. I understand.
So let's just
0.28 would be for everything to the right of it, right?
So let's just pretend that we wanted to say in the top 2%, in the top,
like the 10%.
Top 6%. What's the percentile rank of the top 6%?
It'd be 94. Inverse norm 94. Right?
Percentile rank of is 0.94. So you always have to go by percentile rank. You cannot go, if I say in the top 6%, percentile rank is 0.94. Gotta turn it into percentile rank, and then you would do inverse norm
0.94?
0.94.
So for the z-score there you did inverse norm 0.90, not 90?
0.90,
okay,
that's right.
To the point. All right.
I'm sorry, but can you go over that again? In the top 6% percentile rate is 9.4.
0.94.
0.94. So if you're in the 94th percentile, obviously. Okay. Sorry, I get it.
Right?
My bad.
Yeah.
But honestly, if you don't convert it to percentile, you'll still get the same answer. Because I'm doing it and I get the same answer. Like I got.
You should get a negative z-score though. I'm not saying it's not possible. I mean, remember that the normal distribution is symmetrical. So if you get the lower 6%, to make it the upper 6%, instead of having a negative z-score, you use the positive z-score. So if you can intellectualize it that way, you would be fine. But I worry about high schoolers and intellectualization.
What problem is this?
That was 7. Okay, so we're moving on to question 8. Question 9. Question 9. At a community college, 30% take calculus. 80% of those who take calculus take science courses, while only 40% of those who do not take calculus take science. So I think one way that we can do this, which we kind of forgot about, we got 2 ways of doing this, and I'm going to go through both of them. One way is to use, let's just start with a tree.
I love tree diagrams.
Okay? So we start off with our tree, and we say that what percent of people take calculus? It's calculus and not calculus, right? 30% take calculus, which means that 70% do not take calculus. Now if you took calculus, 80% of those people who took calculus took science, which would mean 20% do not take science. Now if you did not take calculus, 40% of those who did not take calculus took science. They were busy taking something like Norse mythology, I don't know. Okay, so if we have all of this, I could, at this point, just type out everything. So this right here, ooh, no, that's not type. My bad. This is going to be the probability of C and S is equal to 0.8 times 0.3, which is 0.24. The probability of C and S complement, that's 0.06. 0.3 times 0.2 is 0.06. over here, the probability of not calculus yet took science, 0.7 times 0.4, which is 0.28. So 28% of the student body did not take calculus, but also took science. And then over here, the probability of did not take science and did not take calculus,
0.42.
0.42. Wow, that's a lot of people. I don't know what
They're
they're
not
taking.
overachievers.
That's like, I don't know. All right, so question 9 says, what's the probability that a student takes science? Well, I don't know. How many of these are students taking science? This one
52.
and this one. Both of these together are students who took science. Notice that's science and not science complement. So the probability of taking science is equal to 0.52. Question 10. So for question 10, we want to know what's the probability that a student who takes science also takes calculus. So what do we know for sure? Do we know for sure they're taking calculus, or do we know for sure that they're taking
That
science?
they're taking science.
We know for sure that they're taking science. We want to know what's the probability that they're also taking calculus. So that's the probability of taking calculus
Giving that
and a science course divided by the probability of taking a science course. What's the probability of calculus and science?
0.24.
0.24. What's the probability of taking a science course? 0.52. We just did that. And that gives us
46%. 0.4615.
85.
Nope. Nope, you're wrong.
Yeah, I know. I'm wrong.
So it's a probability. So remember, our customary way of doing probabilities is the 4th decimal place. If you plan on using anything else before decimals, please use the word approximately or about. Questions on this one? Yes, sir.
Indicated that Hannah said you were asking for the probability of calculus given the science.
Okay, so the verbiage here that I'm looking at is a student who takes science also takes calculus. So we know for sure that they already take science. So if we know for sure they already take science, that tells me it's a conditional distribution. Okay? Okay, alternative ways to do this is to set up, of course, your table. So the first one we have is calculus and no calculus. Total. Science.
Oh, are you just showing us like another way to do it?
No science. Total. So, how many people can we start off with? Oh, I don't know. In this one, it seems like we can do 100 people. Okay. So out of those 100 people, what percent of them took calculus? 30%, right? So 30% of 100 students took calculus, so 30 kids took calculus, 70 kids did not take calculus. All right, well, of the people who took calculus, 80% of this 30 took a science. So it's 80% of 30.
24.
So 24 students took science. That means the rest of them did not take science. Okay, of the people who did not take calculus, 40% of them took science. So 40% of this 70 took science. 28. That means 28 of that 70 took science, and the rest of them, 42, did not take science. So how many kids took science? 52. How many kids did not take science?
48.
48. So now we should be able to answer every question about this. Okay, so what's the probability that a student takes science? That's 52 out of 100. 52 out of 100 kids took science. What's the probability that a kid took calculus given that he took science? Well, how many kids out of this row, how many kids took calculus? 24. 24 out of the 52 kids that are already in the row. So again, some people like chart, some people like tree. I feel like we have a growing number of tree people.
Yeah, just tree just work its way.
The pathway of it is really easy.
Yeah,
Okay?
because you can literally see that if this happens and this happens, then it goes over.
Okay. Doesn't matter to me which way you do it. Okay, moving on. Next one is question.
Just did 10.
We just did 10, so it looks like 11. So question 11.
Yes.
One of the values in a normal distribution is 13 and has a z-score of negative 2.7. So 13,
2.10.
that turns into a z-score of negative 2.1. So that tells me right there that the mean is greater than 13. Also, they say that the mean is 16.
What did you say? It was greater than? Sorry for interrupting.
The mean has to be greater than 13.
Well, yeah, it gives us the mean. The standard deviation.
Well, I think what I'm going for here is you have a negative z-score, so that means that 13 is below the mean. So the mean has to be greater than 13. So we're supposed to find what is the standard deviation.
You just have to move around the z-score formula to find that.
Right. So we just have to use that z-score formula. So z equals x minus mu.
The standard deviation. Standard deviation equals x minus mu. 1.4.
Oops, sorry, that's a 13, right? That's 13 minus 16.
It's 1.42. 1.43.
13 minus 16 over...
You said 4.3, right?
Yeah. Did I get it right?
Yeah, I think so. Yeah, 1.43. Correction. Statistics. It's kind of like math.
Wait, go up really quick.
I like math better than math.
I actually would rather be taking this in calculus.
I like geometry. Geometry is my favorite.
We do our
What?
Okay. Any question on 11?
I misplaced it.
Yeah.
Is that the recommended
Oh, you know, it should be 4. You're right. Do you give me the other decimals?
286. Wait, sorry. I told you wrong. I told you incorrectly. It's 1.4286.
This is 1.43. It's 1.428.
Stop touching my nuts.
You've been waiting to say that, haven't you?
When is she gonna eat them? When is she gonna eat them?
Oh, and when she does, everyone's going to laugh.
Everyone's going to laugh at my joke.
No, I've done that.
Wait, so how many
Do we have to come to school on Friday?
Usually 4. 4 significant figures, let's put it that way. Alright, last one of the supplemental is question 12. Question 12 says, the weights of professional football players are approximately normal. That's good to know, it has to be normal, with a mean of 245 and a standard deviation of 20.
No, it's more lighter than that.
Standard deviation equals 20. Okay, so Thor, wow. Thor is the 80th percentile. So we want to know how much does he weigh.
Well, his Z-score is 80%.
Yeah, so the first thing we need to do is recognize that we have a normal distribution.
Yes, we do.
And so we're going to use means, or we're going to use methods for normal distributions. And that would mean that the z-score is equal to Thor's weight minus the average weight divided by the standard deviation.
So can we just do inverse norm of 0.8 and we get that?
So z is going to be equal to
It's 0.84. Or do how many digits is in a z-score? 3 or 2?
2.
2, so 0.84.
So inverse norm does tell us the z-score?
Yes.
And then
What did you get for the z-score?
0.84.
0.4?
0.84.
0.84.
It's inverse
And then
norm
we gotta
Of what?
do the
Sorry, give me 1 second. I'll put that in there.
Then we have to change around the z-score formulation to find x.
Inverse norm of 0.80.
This is 0.84.
Why do you think 0.84? Why are you guys all saying 0.84 if it's 80th percentile?
No, for the inverse.
It's
We
the
do
inverse
the inverse
norm.
norm of 0.8.
Oh, which is 0.84.
Yeah.
Okay.
So the percentile rank is
Yeah,
80.
you get to this, you go to second distribution, and then like one like third thing.
So the
That's inverse norm, and you just plug it in.
So
Because the area is
so the
Oh my god.
1 minus 0.1.
so the percentile rank is 80. Therefore, the z-score is 0.84.
Yes.
I know you can hear me talking. I know you hear me talking. If this is a waste of your time, please leave. Okay. Now that I have my z-score, I can apply, or I can look at the transformation. The z-score equals Thor's weight, which we don't know, minus the average weight, which we do know, divided by a standard deviation. I'm not going to tell you how to do algebra.
I got it. 261.8 or 262.
So about 262 pounds.
What is this?
I'm not fine.
262 lbs. And he's Irish.
True data.
Yeah.
When you say approximately normal distributed, then should we say the x value like in terms of approximate?
Yeah, you should. Okay,